Okay, so by remainder theorem, I'm going to let because anyway fx is this, fx equals to x cubed plus ax squared plus bx c. So by remainder theorem, f1 is equals to 8, f2 is equals to 12, and f25 is equals to f3 is equals to 25. Okay. Then you just substitute it in lah. Shouldn't be an issue. So this will be 1 plus a plus b plus c. So 8. Then you have equals to 12. Then 3 cubed. Minus 8. Four. Then this is 9. This one GC. So solve. 1, 2, and 3. Show that the gradient curve is always positive. Hence, explain why fx equals 0 has only one real and find this root. Okay, this is pretty okay. So part 2. Fx equals to x cubed minus 3 over 2x squared plus 3 over 2x plus 7. So f prime x will just be 3x squared minus 3x plus 3 over 2. So I think this is pretty okay. There are two methods here. I think I prefer completing the square. You just want to show that this is always positive. The other one is you can use discriminant. Method 1. Method 2. Complete the square. Okay. Complete the square is more rigorous, I will feel. That's how we fx. We just complete the square. 3. Just okay. Just slowly. Then just key in calculator, should be fine. So f prime x is equals to 3 x minus half square 3 over 2 minus 3 over 4. So since x minus half square is at least 0, so hence so gradient of a curve is always positive, hence okay. Then the second one always positive. You can just use discriminant. B square minus 4ac is minus 3 square minus 4 times 3 over 2. This would be negative, I believe. And A is equals to 3 is positive. Hence f prime x. Yeah, can also. So either way, I think both will work. Okay. Conclude lah. Okay, so same thing. Let's go back to secondary school. You know that for a cubic function, a bigger than 0, where it's positive, right? There are only 3 cases, right? You have got one is the reason why they want you to explain that only have one, is it one real root? They say explain why it has only one real root. So this is what is going on. This is the increasing function. So if your cubic, one is like that, right? This is one shape, right? The other one is like that. If it's the x cube, the coefficient x cube is positive, then it'll be like that. This is where gradient is 0. Then the other one is like that. So this is where dy dx goes 0. So we just recap some of the concept here. This one is what we call this both is called what? Point of inflection, right? But these both are called points of inflection, but there's only one stationary point of inflection, which is this, the middle one. Okay, I repeat, they are both called points of inflection. Okay, but this is a stationary point of inflection. This is just a typical point of inflection. So let me just recap this. You have okay, I'll just write this down. This stationary point of inflection. This one here is just a typical point of inflection. What is point of inflection? Point of inflection is where the point where you change concavity. Change in concavity. So in our prelim revision set, we already discussed this is concave downwards here. This is concave upwards here. This is concave downwards here. This is concave upwards here. All right. So for cubic function, you will change the concavity at the point of inflection. But there's only one which is called stationary point of inflection, is when this value here is dy dx equals to 0. This one obviously, so if our f prime x is bigger, always positive, which case you're looking at? So the question is asking you to decide which one is it lah. Okay, this one obviously the gradient is not always positive. You have one positive here, then you have one negative here, then go up again. So this region here, there's a negative gradient here, right? So this is obviously not, because this is dy dx is not always bigger than 0. You have a dy dx here, which is like negative gradient. Write it down for you, where dy dx is negative, then here is dy dx is positive. Okay, this one is f prime x is at least 0. Can be 0. This is f prime x is bigger than 0. Okay, so the question is asking, using this concept here, always positive, how come this is always bigger, only have one real root lah? Okay, it's very clear, because if the shape of the graph is like that, no matter what you draw your x-axis here, you only cut the horizontal line once. Okay, whereas for this one here, yeah, also once lah. You also cut it once. This one also cuts it once, so it works as well. So no matter where you cut it, put place your x-axis, only cut one. This is the one which is the culprit, because if you this one can cut 3 times. If you draw like that, then if you draw this one like that, you cut twice. Okay, and so on. Then you cut once. Okay, so this is the graph that you're looking at. So if you plot in your GC, the shape will look like that, right? I think it's like that. If you key in calculator. Okay, so understand what they're asking. You're looking at the gradient, the graph. Using the gradient to show. It is quite a nice question, because there's only one way to answer it, which is to say that because there's no max and min point, no turning point. Okay, so since this is all right, since f prime x bigger than 0, y equals to fx has no turning point. And strictly increasing is a strictly increasing function. Okay, means that this is how I write. You don't need to write like how I write. Okay, but this is the gold standard lah. So meaning to say, the horizontal line, I give a generic line just like the one-to-one test, y equals to a, will cut fx once. Okay, thus fx. I know you will not think of the horizontal line, but that is how I write. But you don't want to follow me. You just say no turning point, cut once, okay already. So thus fx has only one root. Okay. Okay, so this is one. Of course, you can put y equals to 0 here, not an issue. But I just put a generic one. So I just want to say that no matter where I place my x-axis, it will only cut once. So from GC, solve. The root is then you get this graph. Oh, so you need to zoom standard. Then you just find the root lah. Find the root, it shouldn't be an issue, right? 0. Yep. The last part should be quite fast, right? Oh, last part should be quite fast. This is negative 1.3299. So this one from GC. Okay, this is how. All right, so you don't need to draw the diagram out. This is just for explanation. So the last one would be x coordinate of the points where the tangent of the curve to dy dx is parallel to 2x minus 3 lah. Okay, shouldn't be an issue. For part 3, you want tangent parallel to y equals to 2x minus 3. So we need to say dy dx is just equals to 2. So this is just secondary school question. It's exactly like A math. Nothing fancy there. Dy dx just now we found. Dy dx 3x square minus 3x. Then they never ask for exact. Please don't go and give exact. Okay, so don't need to give exact. Just give them. Don't waste time. Then from GC, so x coordinates are